We know our formulas that we can use. Am I right on this? Great. So. Okay, so which ones do we know?
Height of the object.
Okay, so height of object.
Distance of object. And the distance of image.
Do we know those? You know the height of the object? 4 centimeters. Okay, so that came from there.
Distance of the object.
So our distance came from that spot.
And distance of the image is 13.2 centimeters. Focal length is 15.
So it's our focal length, our value that we know is 15.2 centimeters. Okay, so then we need to find, it says distance of image, which is di, hi, which is height of image, and magnification, which is our question mark. There are two formulas that we have, right? We have this one, and the second one. Okay, so then we are just going into this and plugging things in. So if we look at this magnification one here, I have two unknowns, so I can't answer this one yet, right? If I had a magnification value, I could solve for one of them. So remember that this whole equation equals each other. And then we also have this equals each other. This equals each other. This equaling that. That's what all of those mean. They're all equivalent to each other. They all have purposes to it. Okay, so you can choose any one of those sections in order to answer. So if I had a magnification and a height of object, I could find my height of image. And just solve for those three. If I don't have to do magnification, then I could just, if I had those three values and I was looking for this one, I could solve for it. Okay? In this case though, I'm missing two variables at least, no matter which way I go, so I can't do that. So yes, I gotta do the top one. Okay, so we're gonna do the top portion. So with my top portion, I'm just plugging it in. So I have 1 over f, which is at 15.2. Big thing is to make sure that all my units are the same. They're all centimeters, so I'm going to keep going. Then I have 1 over di, and plus 1 over, what was my 47? Yeah, thank you. Okay. My suggestion to you is to find the decimal version of this. Makes your life easier. Start with. That's the way I would do it. Okay, so I would find out what the answer is for this one and this one, and then move it over and solve. Okay. So I don't have those values in front of me. So I'm help me out. 0.006. 578947. I'm lazy. Thank you. And on the other one. 0.021838. Great, so moving this to that side, subtracting it, right? So this value subtracted by that value. So remember that there's a really long version of doing this to find out our DI. Well, we should know our short version, that this and this false box. But if I wanted to, DI multiplied on this side to this side, and then I take this number and I divide it, and we're just gonna flip up. Okay, so my DI is going to equal 1 divided by that value, which is 0.
I got 22.
Sorry, 22?
Yeah. 22.77.
Okay, so now I have its DI value. Okay, we should realize that this one is going to be that negative value because that negative tells me that it's a virtual. Right? So that's where that, I'm going to use different color here. It's negative because virtual. Right?
Because it's an image.
Yes, because it's the image. Yeah, good point. So because it's virtual and it's the image. If it's talking about the object, you have to have a positive value because it'll be on this side. So from there, we're going to now plug it into our big equation and solve for each part. Okay? So, first one I would do is magnification. So magnification is negative DI over DO. So I'm just looking at that because I have DI and DO. I'm going to just plug in those values. So that's negative 22.78 centimeters, and this one was 45.7. Yes? Okay, so dividing those two out, what do I get here?
Negative 0.49.
0.49846. Okay, I'm going to stop there. Remember that our units for this is like in X, let's say times, or magnified, right? The other units cancel out, the centimeters cancel out, so it's just saying that it's this much bigger. Okay. From there, I now have a magnification value. I have a height of object, and I need to find height of image. Is that right?
Yeah.
Okay. So I'm just gonna extend down. Are we still doing okay?
Yeah.
Okay. So magnification is height of image over height of object, and I'm plugging them both in. And this was 4 centimeters, right?
Yeah.
I'll solve for it. It's dividing. I'm going to multiply on both sides.
Negative 1.99.
Okay, and this I'm going to add my centimeters. Okay. And then, the only thing that we have that we're gonna kind of argue with here is that object and image heights are positive if they're above the principal axes and negative if below. So if we are dealing with a diverging mirror, so if the equation dealt with a diverging one, we would have to note that it will always be positive because it always has to be above. Does that make sense? In this one here, depending on how it's drawn out, will determine if it's positive or negative, right? So I made it negative based on when I plugged in that number, right? But I can't say is this a negative or positive. I have to look at it. Does that make sense? You have to draw it out. And so in this style, we would have to decipher that. Does that make sense? So at this time, my only unknown is this really correct? Is it actually a negative? Okay, because it's converging? Alright.